Hello friends, welcome back to our episode 3 on design pattern discussion. And today's topic is OCP pattern, which is nothing but open close principle, or sometimes it's also known as open for change but closed for modification pattern. I know it sounds a little confusing, so let's understand the concept with a real-time example first. So let's say we have a standard SAP program and we need to enhance this particular application with certain custom feature. So there are many techniques there. One of the best way should be implementing a buddy approach, which is a business add-ins. So which is nothing but an interface which SAP offers as a hook, and we customers or partners using the buddy implementation, we put or inject our custom code. That's why what happens, we achieve the new features or functionality that we are looking at. But by doing that, SAP is ensuring that our code is not breaking the existing SAP program, which is already been tested by SAP and it's working. So how they are ensuring? Obviously by setting up a hook, and they are saying like, I'm open to accept a new change, new custom logic, but I'm closed for modifying my own existing code, which is working fine. So this is the OCP pattern or open close principle. So definitely most of you have already used these concepts knowingly or unknowingly. So let's understand another example, which is also interesting, and very often we encounter such kind of scenario in real projects. Now let's understand, we have a program or a business process logic, and which does lots of processing, and eventually the outcome we want to display it as an ALV list viewer, or it may happen the outcome we want to download in a local system, or even the same file we can download in application server. And this representation of the outcomes keep on changing, because tomorrow may happen a new requirement arrived which says that I have to email the outcome to a specific user list. So that means this particular requirement keep on changing, and the representation of the outcome is varying. So in this case, in general, what I have seen people writing a code like this, they are checking if and else if kind of a logic. So if radio button ALV is selected, then call the ALV method or ALV function. Similar way, if file download to PC is selected, call a download function, and so on and so forth. Keep on changing. So that means if tomorrow we have a new requirement about an email functionality, then we have to come back to this code and we have to add one more line for else if the email function is selected, then call email function. So that violates this open close principle, because we are not allowed to change our original code which is working fine before. So how we can resolve this problem? That definitely learn through an exercise, but obviously you can assume or you can guess that the best approach should be some sort of a baddie or kind of an interface, which you have learned in example 1. So let's do that now. So let us now solve this exercise using the OCP principle. So let's assume that different type of shapes you will enter as an input to this particular function, and the function job is to calculate the area as per the given input. Now in general, we would create some if-else conditions, but as we have seen, that violates the open close principle. So without using if-else, how we can achieve this particular solution? So very simple. As we can anticipate, we will not be using if-else, but we'll be creating some interface this time, which is a buddy hook in another way you can think through. So depending on the shape, you have to create different classes, and each class will implement the same interfaces, so that the process, which is the calculate area in this case, doesn't have any clue about these 3 individual classes, but it knows the interface. So using this interface, it will be able to call that particular class which is representing a particular shape as an input. So let's do that in a ABAP code, as well as I'll explain this OCP principle or open close principle in JavaScript programming language as well. So I'm very sure and confident that you have understood the purpose of this open close principle, and I use this pattern quite often for my projects as well, because it helps to avoid regression. That means the program which was working fine in production, even after put a new change, my program doesn't break. So here's my ABAP transpiler, and I have written the enter code for you just to save certain time. So we'll start with an interface first, as we discussed. So this is the interface that we're going to create first. And I have given a name of a method called calculate area, and it returns a area value as a string. I have one individual class for the rectangle. You just follow along the naming convention like LCL underscore the shape name. So this is the pattern I'm following. And I have implemented the same interface which we just declared, so that the calculate area method is now available for me to implement. And I have just written a very simple logic, multiplication of length and breadth to calculate the area of the rectangle. That's all. Similar way, the circle I have created as an individual class and implemented the same interfaces now. And now I have a provision to implement the calculate area method. And I have just implemented simple logic like pi r square to calculate the area of the circle. Now this is the main function, which is LCL underscore main. And here you see there's two things. One is the class method, which is a static method. And the name of the method is again calculate area, but this time it takes input as a shape. So it takes the shape name as the input. And here one of the object that I have declared, and this object is refers to that interface. You see, this class LCL underscore main doesn't have any clarity or any clue about the individual classes that we have just declared above, like circle as well as the rectangle. So it knows the interface name for this class is available. You see, this is the interface it knows, but it doesn't have any clarity on the on individual classes. So now we have to declare that we have already declared the method. Now we have to implement this logic. So what I should do basically, we'll call this calculate area and we'll enter the shape name as an input. So inside this method, what I'm doing, little tricks, and that is I'm concatenating LCL underscore followed by the uppercase is the function and giving the name of the shape, so that it will create or generate dynamically the class name, and the class name is following the same pattern as I just mentioned. So now I have a provision to use the same class to be used dynamically within a parenthesis, and my object, which is yellow shape, will be referring to that particular class, whichever I'll pass it on as an input. So now if I just remove this comment code, I'll see the area been calculated for the circle. So it knows like which method, which class will be needs to be triggered based on the shape name. I'm generating the class as LCL underscore circle, and it goes via to this class and calling this method and returns the area of the circle. Similar way, if I just remove this one as a new shape called rectangle, and it calculates the area of the rectangle, and you see I don't need to make any modification for this code. So this way the OCP principle is still remain valid, whereas I am still able to add more shapes as an input. Obviously I need to create dedicated classes for that. I hope you understood this one for the ABAP perspective. So let's do kind of coding for the JavaScript part. Now for JavaScript also, we don't have that interface syntax, but we do have a class syntax definitely. So I have created a class syntax this time and declared a person class. Now I have a constructor which just takes first name and last name as an input, and it just fills the value to that variable. And I have declared one more function called print name, and it just returns this particular string with a text literal used like first name and last name. This is the value I'm just passing as a string. Now in JavaScript, as I said, interface is not there, but yeah, this interface syntax though available in a TypeScript, but that is a superset of JavaScript, but we are not using TypeScript in this case. So what we'll do, we'll basically do a method overriding. So I'm just declaring one more class called developer, but I'm just inheriting from the person class, right? Because developer is a very specific uh, object of a person, because person is more a generalized one. So there I added one more constructor, and this time I'm adding up a skill for the developer. So by process, we need to call the super constructor, and at the same time, I'm assigning a value as a skill to this local variable. Now I am overriding this print name function, because print name is from person class, ideally if I don't override, but I'm overriding and I'm just writing a different one, like I am this name and I know this particular skill. So this is what I'm just declaring. So as you can see, this is the way we are, doing a method override, which also did for the ABAP part. Now coming back, so let's creating now an object for the person and giving the first name and last name as John Doe. And now I am just, doing a console log for the print name. So what will happen? So this dev1 is the object which is referring to this person class. So that means it will call this print name method, right? So I'm just doing a console log of this one, and obviously I know it will be printing like my name is John Doe. And similar way, I have created one more object for the developer, and I'm passing the skill this time as well. And if I just print it, what will happen? This time it will go to the override method, which is here in this case for the developer class, and this time it will print like, hey, I am so and so, and I know this particular skill. So let's run that one, and I'll just run node index, and this just open it a little, maximize. You see the my name is John Doe, and I am the second outcome is from here it is printing like I am Somnath Paul and I know JavaScript. Now in JavaScript there is a cool concept, and that is called prototypal inheritance. So the object which we are referring as person, so let's uncomment this code and let's think what's happening now. So person is the class, which is the main class over here, and I'm using prototype dot print name. So I'm just adding a print name function as a prototypal basis, so that what will happen, this particular print name will get the more priority than the print name of this class itself. We'll see in a debug mode soon. And now I'm saying this print name should be, hey, my name is so and so. So if we run this code, what will happen now? This print name from dev1, which is an object of person, will not go to this print name, rather it will come to this particular overriding method, the prototypal function declaration or function expression declaration. So let's save this one and run once again, and you see, hey, my name is John Doe. So this is what is getting printed, right? Now it is also printing undefined, and that because I have doing a console log and this method is not returning any value. So what we can do is, maybe we can do something like that. We can remove this console log completely, and if I just now run it, we'll see, hey, my name is John Doe and I am Somnath Paul. So you can understand this gets some more priority than this print function. Okay, so similar way, if I also do a prototypal function to this developer class, and I'm just giving some funny thing like, hello, my name is something. So if I just save it, similar way, let's do just remove this, because this function also not returning anything. So to avoid the undefined as a result, remove this console log, run once again, and you see, hello, my name is Somnath Paul. That means this is getting called, but not the print name of this developer class itself. So you now understood how the prototypal inheritance works, and this is the technique we use in JavaScript to do a method override approach. So similar thing, whatever we have done for the ABAP for overriding through interface, we'll do overriding through inheritance. Okay, so that's the only difference, but it works this way for JavaScript too. So that's all for today. Thanks for watching, and I hope you understood the context and the power of this OCP, open close principle pattern, and definitely will try using your project. So we'll see you soon with the episode 4 with different pattern. Thanks for watching and stay tuned.